Okay guys, today we're going to look into how to draw double and triple bonds using the skeletal structure format. Okay, double and triple bonds, these also contain the pi bonds. So they have, the hybridization changes. And so you've got some of that craziness going on. And so we need to kind of talk about how to draw those. Okay. So let's draw, let's start with a 4-carbon chain. So let's have 1, 2, 3, 4. Okay, so let's number our carbons. 1, 2, 3, 4. Okay, now if we have a double bond, so we have a double bond, that means it's going to be sp2 hybridized. Now, again, we're drawing these at approximately 120-degree angles. Now, here's the cool thing. Remember, I don't really care about bond angles, but some people do, so I'll at least tell you about them. The sp2 hybridization is trigonal planar, which actually does have 120-degree bond angles. So this is actually going to be correct. Okay, now eventually we'll learn how to denote where to put the double bond. Now, this is really easy, okay? Let's say we're going to put the double bond between carbons 1 and 2. You just draw another line. Most of the time it's going to be a little bit shorter, and again, you don't have to be a very good artist. Now, you could also draw this like this, above it. That's fine. As long as you have 2 lines, that's a double bond. Simple, right? Okay, so these two are the same. Now, if we have our 4-carbon chain and now it's between these two, these are not the same. They may have the same formula, but these are not the same molecule. Double bonds in different place. So again, we'll talk more about that later. Now, when we do triple bonds, this is where things get really confusing, okay? So you need to make sure you get this right and you can count, all right? So triple bonds are sp hybridized, and if you remember, that means they're going to have a linear. So when you have a triple bond, you need to break from this alternate form. So that's going to be a little bit strange, but you're going to see why a little bit later. So let's have a 5-carbon triple bond. Okay, so and we're going to do a 5-carbon chain, and we're going to have our triple bond between carbons 2 and 3. So the way we're going to do this is you just kind of have to count with me, okay? Because our triple bond is going to be linear, all right? So we're going to do 1, 2, 3, 4, 5. You go, Dr. B, what'd you do? Right. Okay. So here, you heard me say this. So you see how I had this little dot where I just kind of hung out for a little bit? So here, 1, 2, 3. So this is our triple bond. Actually, I should probably do that better, but you can also draw it 1, 2, 3, 4, and 5. This is probably the best way to do it at a full line, because otherwise this can get really tricky. So here, this is probably the easiest thing. So this is when we're numbering this: carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. So if you're really careful, this can be, kind of okay. But if you're not good enough with your lines and there's a little bit of space, I might have actually drawn 6 carbons. So like, what if I did this? So this could be 1, 2, 3. This is now 4, 5, 6. That's bad. Okay, so you have to be careful. If you're not a good artist, do this. Okay, so we need to draw. So if we have this 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. So these look a little bit different, so you just have to be really, really careful. So I was supposed to draw 5 carbons, and I left a little bit of space. That was accidentally 6. So be careful. Look for lines. Again, get in the habit of numbering your carbon.